In this tutorial, I'm going to show you how to take a regression output like the one shown here and use the sum product formula to explore the effect of one variable on another. And this regression output is from one of my softball regressions, and in particular what I did was I'm predicting how far people can hit a softball as a function of a male dummy variable that equals 1 if the male, 0 if female, and a variable for experience. And experience is the number of years the hitter has playing on a softball or a baseball team. And then down here I've got two tables, and in each table I have the same variables and coefficients. And there's also a column for variable values where we can plug in different values for male and experience. And then we have a sum product formula at the bottom, which does the sum product thing where it takes the coefficients, the variable values you've assumed, and calculates the predicted hitting distance. And as you can see here, starting off, we have for both tables the male variable is 0, so we're talking about a female. The experience variable is 0, so this person has no experience playing on a softball or baseball team. We always multiply our intercept by 1 just to keep it the intercept, and in both cases we find that the hitter is going to hit about 75 feet. What we want to do now is we can explore the effect of different variables. So let me come over here and suppose I say, well, instead of being a female, what if they're male? Meaning, what if this dummy variable goes from 0 to 1? Well, we see that our predicted hitting distance goes up to 143 feet. Now I'm gonna do something. I'm going to create a cell here which takes this prediction and subtracts that prediction from it. So I'm taking 143 minus 75. And when I do that, I find that difference, the difference in the predicted hitting distances, is 67.71. Well, notice that's exactly that coefficient value for male. And that's what the male does. Based on the data, males hit about 67.71 feet further. Now let's suppose, let's make them a female again, so they're both female. Now let's suppose that, and I'll get these, this is person A in the first column and person B in the second column. And let's have the experience for person A go up by 1, so I'm going to change experience from 0 to 1. And now we predict they hit 78.76 feet, and the difference between person A and person B is 3.45 feet, which is exactly the coefficient for experience. And that's what the regression is telling us. On average, for every additional year of experience playing on a ball team, people are going to hit about 3.45 feet further. Now let me do a little experiment. This regression shows us that males hit further than females, but that people can hit further as they gain experience. So what I want to know is, how much experience does a female need before they can hit just as far as a male with no experience? So what I mean is, I'm going to make person A a male, and I'm going to make person B a female, but I'm going to start giving person B or female some experience. So our male with no experience hits 143 feet, or our female with 1 year experience hits 78.67 feet. So the male still hits further than female. Let me give the female 20 years of experience. Well, now the female hits a little further than the male. Let me make it 19 feet. No, and so a little less. So roughly, a female needs about 20 years playing on a softball or baseball team before they can hit further than the average male who has no years of experience. And that's what I like these sum products for. You can create two tables like this and really quickly explore what happens when you change the value of explanatory variables.